The formula for calculating formal charge is going to be watts minus ohms. That's the way that I like to remember it. Calculating the formal charge of an element can be fairly simple if you can keep in mind two things. One is the formula for calculating formal charge, and two is the number of electrons in the ground state neutral configuration for that element. The formula for calculating formal charge is going to be watts minus ohms. That's the way that I like to remember it. The formal charge is the number of electrons the element wants in its neutral ground state configuration, minus the number of electrons the element owns in this particular molecule. We'll talk about that as we go through these examples. To figure out how many electrons the element wants in its neutral ground state configuration, we can look at the periodic table. The periodic table tells us what group number each element is in, and the ones digit of that group number is a shorthand for how many electrons that element wants in its neutral ground state configuration. Carbon is in group 14, the ones digit is 4, so carbon wants 4 electrons in its neutral ground state configuration, and so on for the other elements. The way to actually figure out is to look at the electron configuration for a given element. Carbon is 1s2, 2s2, 2p2. We look at the valence shell, the 2 shell, the sum total of the number of electrons in the second shell is 4. So carbon has 4 valence electrons. Nitrogen has 5, oxygen has 6, and so on. These are the number of electrons the element wants in its neutral ground state configuration. For the other part of this equation, an element owns all of its non-bonded electrons and half of all of the bonding electrons attached to that element. Let's start with this carbon on the top of this fictitious molecule, and let's work through all of these examples. There's no possible way this molecule could actually exist. It would be really unstable, but this is just for example purposes. If we look at this carbon, the formal charge calculation for this carbon, carbon wants 4 electrons in its neutral ground state configuration, and it owns the 2 lone electrons and half of the 6 bonding electrons, so 2 plus 3 is 5 total electrons that it owns. 4 minus 5 equals -1, so the formal charge on this carbon atom is a -1 formal charge. Let's keep going. The oxygen here. The formal charge for oxygen. Oxygen wants 6 electrons in its neutral ground state configuration. It owns 1, 2, 3, 4, 5, 6, and half of the 2 bonding electrons, so half of 1. That makes a total of 7 total electrons that it owns, which 7 minus 6 is also -1. Oxygen here also has a -1 formal charge. Nitrogen wants 5 electrons in its ground state neutral configuration, and it owns half of the 8 bonding electrons, so it owns 4. 5 minus 4 equals +1. So the nitrogen in this particular example has a +1 formal charge. This oxygen wants 6 electrons in its neutral ground state configuration. It owns 4 non-bonded electrons. There's an implied bond here between oxygen and hydrogen, so it owns half of the 4 bonding electrons. So it owns 1, 2, 3, 4, 5, 6 electrons. 6 minus 6 equals 0. This oxygen is neutral. This carbon in this structure down here does not have any non-bonded electrons, and it has 8 bonding electrons. So carbon wants 4 electrons in its neutral ground state, and it owns 4 electrons equals 0. This carbon is also neutral. For this nitrogen, nitrogen wants 5 electrons in its neutral ground state configuration. It owns 1, 2, 3, 4, and half of those 4 for 2, so that makes a total of 6 electrons that it owns. 5 minus 6 equals -1. This nitrogen has a -1 formal charge in this structure. Oxygen wants 6 electrons in its neutral ground state configuration. It owns half of the 6 bonding electrons and both non-bonded electrons, so that's 5. 6 minus 5 equals +1. This oxygen has a +1 formal charge. Now this carbon is interesting. Carbon makes 4 bonds. We often assume in line angle structure that there's enough hydrogens to make it to 4 bonds, but remember our line angle structure rules. If a carbon is explicitly written, we have to write in its hydrogens, and since no hydrogens are written here, we should assume that there are 0 hydrogens attached to this carbon. So the formal charge calculation for this carbon atom, it does not have any non-bonded electrons. It wants 4 electrons in its neutral ground state configuration, and it owns 3 electrons, so that is a +1 formal charge on this carbon atom. Finally, for this nitrogen atom, nitrogen wants 5 electrons in its neutral ground state configuration. It owns 3 bonding electrons and 2 non-bonded electrons. That is also 5. That equals 0. So this nitrogen is neutrally charged in this structure. So these are some examples of how we can calculate formal charge. I would highly recommend that you memorize the charge patterns for each of the elements rather than having to go through this calculation every time, and I've got a link to that video below. This is how we calculate the formal charge for any given atom in a molecule.
I'm glad you're here with us for this training today. Check out these other videos in my playlists to see if there's anything else that can help you level up your ninja levels even further. As always, don't forget to like and subscribe.